let's get one thing straight. The AI race, it's over. That whole story you're being sold every single day, it's just plain wrong.
You know the narrative. You hear it everywhere. The race to AGI is on. It's painted as this thrilling software sprint, a few genius labs battling it out to cook up the smartest algorithm.
Yeah, well, that race is completely obsolete.
The reality is something way more brutal. This isn't some clean software race. It's an industrial siege. It's a war of attrition. And the real constraints? They're physics, capital, and just raw, brute force energy.
So let's talk about the first front in this war. And it's not against a rival lab or some secret algorithm. No, the first front is a war against physics itself. The biggest thing holding AI back right now is, believe it or not, thermodynamics.
Just to give you a sense of scale, a standard AI cluster, one that's set to come online in 2028, is going to need 10 gigawatts of power. To put that in perspective, that's the entire power consumption of Washington state for one cluster.
And it just gets crazier from there. The demand is escalating fast. By 2030, a single Stargate-class cluster, we're talking a projected 100 gigawatts. That is more than 20% of the total U.S. electricity output for one machine.
Okay, so you obviously can't just plug that into the wall. The public grid would literally break. Think about it. Transmission upgrades take 10 years or more to build out, but AI is scaling every 18 months. The timelines don't even come close. So what's the solution? You have to decouple. You go off-grid. The big AI players are now forced to become energy companies. They're building their own power plants right next to their data centers. Right now, they're using natural gas to bridge the gap. But the end game, the long-term solution, is nuclear, specifically small modular reactors.
And this means we're seeing this incredible physical transformation. You have to forget everything you know about old-school cloud data centers. With those racks pulling 8 or 10 kilowatts, cooled by big air conditioners. That's ancient history. We are now in the age of the AI factory. Here, a single rack can burn over 500 kilowatts. And the only way to stop it from melting is to pump liquid coolant directly onto the chips themselves.
But even that, pumping liquid, has a hard physical limit. There's this concept in thermodynamics called critical heat flux. So what is that? It's the exact point where the GPU gets so hot that the liquid coolant touching it flashes into vapor instantly. It creates this tiny film of gas right on the chip surface. Now, why on earth does that matter? Well, that vapor film acts as an insulator. It's like wrapping the chip in a tiny hot blanket. And when that happens, heat transfer doesn't just slow down, it catastrophically collapses. Your ability to pull heat away from the chip plummets. We're talking from over 330 watts down to just 41. The GPU literally cooks itself to death. This isn't a software bug you can patch. It is a hard wall of thermodynamics. So, as if fighting a war against the laws of physics wasn't hard enough, there's a second front opening up, a battle against economic extinction. The whole business model for generative AI, it's teetering on the edge, defined by this huge, gaping chasm between how much is being spent and how much money is actually coming in. This chasm even has a name. They call it the air pocket, and it is a staggering $500 billion, a $500 billion gap between the insane investment in infrastructure and the actual real-world revenue AI is currently pulling in. And when you look at the math, it's just brutal. It basically maps out a path to insolvency for a lot of players. The industry is burning through something like $300 billion a year on infrastructure alone. Just to justify that kind of spending, they need to be making around $600 billion in revenue. So what's the reality? They're bringing in maybe $100 billion. For some companies, the market is priced in a growth expectation that's 60 times their current revenue. That's not optimistic. It's a fantasy. It's completely unsustainable. This whole situation creates a stark divide in the industry between what we can call the renters and the owners. The pure-play AI model labs, they're renters. They have to pay full market price for their GPUs. That means they're paying NVIDIA's margin plus the cloud provider's margin on top of that. This puts them at a massive structural disadvantage against the hyperscalers, the owners. These guys, the Googles and Amazons of the world, they own the whole stack. They design their own custom silicon. For them, the cost is basically just the price of energy and sand. They can drive the cost of running AI models, what we call inference, down towards zero and easily survive a price war. The renters, they just can't compete on that level. And that revenue we talked about, it's pretty flimsy too. One analyst had a great line for it. He said a lot of the reported ARR, annual recurring revenue,
is really ERR, experimental recurring revenue. What does that mean? It means customers are just playing around. They'll use GPT-4 one day, then jump over to Claude the next. Why? Because the underlying models are becoming commodities. There's almost no customer loyalty. All right, so we've got a war on physics and a war on economics. And what that leads to is the third front in this whole conflict, a fractured supremacy. The old idea, the one where a single company wins it all with one godlike model, that idea is dead. What we have instead is a fragmented landscape, a matrix of highly specialized dominance. So if you look ahead to early 2026, you won't see one clear winner. Instead, you'll see a bunch of different champions in different arenas. OpenAI will likely lead in that deep System 2 style reasoning. Google's Gemini is going to own native multimodality, effortlessly blending video, audio, and text. Anthropic's Claude is positioning itself as the go-to for enterprise, for reliability and actually using a computer to get stuff done. And while all that's happening, Meta's Llama is commoditizing the whole game with its open weights models, while a player like DeepSeek comes in and just shatters the training cost. See, everyone is winning their own little war. Now, in this fractured world, probably the biggest strategic move we're going to see is the partnership between Google and Apple. With Gemini powering Apple Intelligence, this isn't just about adding a new feature to your iPhone. No, this is a strategic blockade. Google instantly secures distribution on billions of devices, and in doing so, it effectively locks its competitors out of the single most valuable user base on the planet. The economic fallout from all this is, well, it's brutal. It's leading to something people are calling the SaaSicer. The big, scary realization that's slowly dawning on everyone is that AI agents aren't just another feature you add to your SaaS product. They are a replacement for the SaaS product itself. And that insight is triggering a massive valuation crash for all those software companies built around selling seats. When you put all these pieces together, the physics, the economics, the fractured market, it all points to one thing. We are entering a new industrial age for AI. And in this age, winning isn't about having the cleverest algorithm anymore. It's about having sovereign, undeniable control over the entire physical supply chain of intelligence. Victory in this new age really comes down to 4 pillars. First, thermodynamics. Can you actually build and power a 100-gigawatt nuclear-backed AI factory? Second, vertical integration. Do you own your own silicon so you can survive the inevitable price war on inference? Third, data sovereignty. Can you get your hands on the proprietary, private data inside corporations that's needed to unlock true reasoning abilities? And finally, fourth, capital resilience. Do you have a big enough war chest to survive that $500 billion air pocket? So the new reality is actually pretty simple to state, but incredibly hard to achieve. The future will be dictated by whoever can convert raw energy into intelligence at the lowest possible cost, both thermodynamically and economically. So forget the AI race. That sprint is over. The future doesn't belong to the smartest software coders. It belongs to the masters of the physical world.